So we're going to start the session. Welcome, everybody. We're going to cover Soldering 101. Melissa Vilardo worked at Keslow Camera in LA for 7 years. She was like making power cables and all sorts of cables for Keslow for quite a while. Trained a bunch of people how to solder. So it only seems fitting that she can show us the real basics of 4 important connectors that we see in the field all the time: 2-pin, P-tap, XLR, and actually a Y cable. So if you want to power 2 devices over 1 cable, and we'll have time for questions and answers and whatnot throughout the session. But Melissa, feel free.
Can there be another session where we vote to never use P-taps again for the rest of our lives?
I wish. we almost didn't cover it in this class, to be honest.
I would rather go for never using HDMI ever again.
Oh yeah, I'd vote for both of those.
Yeah.
All right. So sorry, I apologize for interrupting. Let's roll.
It's all good.
Yeah. Well, hello everybody. Yeah, like James said, I was a camera technician at Keslow for 7 years. I trained a lot of the new technicians that would come in, and like Keslow usually like to bring in people that were like capable but hadn't had formal training. That way we could train them the way that we thought they needed to be trained, and they didn't come in with like preconceived notions of like, well, at this place I used to do it like this. So I taught a lot of people who had never seen a soldering iron before, and that's pretty much how I approach this class. So no question is too dumb.
Yeah. Everyone feel free to ask the dumb questions. This is a soldering basics class.
So yeah, originally we just, kind of did it run and gun guerrilla style, just doing what we thought was best. But then we actually had some formal training that Keslow provided from some company called Omni Training. They did like an 8-hour session, and it definitely opened our eyes to a lot of our not the best practices, and improved a lot of our soldering so that we didn't have cables break nearly as much. So I'll definitely let you guys know about the things that you can do to keep your cables as safe for as long as possible, so they'll last you. I mean, they'll be on carts, so they won't be moving around too much, so that's good. But yeah, hopefully we'll help you make some cables that will last for a long time. So yeah, I think that's it for my intro.
Yeah, let's get started.
Yeah, let's get started. So the first thing when you're setting up a soldering station is to be very aware of the environment that you're going to be soldering in. Make sure it's not like a closet, because solder is toxic or some of the byproducts from soldering is toxic. So the ideal thing that you would want is a fume extractor, because that literally you put it right here, and it literally pulls the solder fumes away and filters it into cleaner air. I haven't had the chance to get one for my home kit yet. So I have a box fan behind me, and I'm right next to a window. So I'm just literally creating a big wind tunnel for the solder to pass through, the solder fumes. That's the most important thing. You want to make sure you're in a well ventilated area. And yeah, you either want like a little table fan, some sort of box fan, or ideally a fume extractor. Yeah, why don't we go over some tools? There are quite a few that you will need to make soldering easier for you, especially with these tiny little connectors like the 2-pin Limo. So first you will need an iron. I know Carlos already went over this in his class. I think it's the W51, the tried and true mid-range. Mine's got a digital readout. Let's turn that on. Get a little solder stand, which is always good. Ideally, you want like a spool of solder next to your iron and your everything else. That way you don't have to like hold it in your hand and deal with it this way. You can literally just pull it off the spool. Again, those are on my wish list of soldering supplies to come. So yeah, you'll need solder. I really like this, what is it? 0.032 gauge of solder. It's really small because it fits in the cups of the 2-pin Limo. So you can literally put the whole piece of solder in there, and that'll help with a trick that I'll show you a little later. So yeah, iron. You want to make sure that if you don't have the nice little wire mesh like thing that Carlos has, and you just got the sponge, you always want to make sure the sponge is wet. Otherwise it won't really help you clean solder very well. This is not really necessary, these helping hands. I actually find that they're way too dinky to handle like holding connectors and things, especially if you use like thicker gauge wire where you're like manipulating the wire around and the connector like comes loose and stuff like that. I much prefer a table vise. I believe in Carlos's class you mentioned the Pana vise. I think I had that for a long time, and then I found this guy at Harbor Freight. It's a suction vise, and it's been solid. These little pads here seem to hold up to a lot of heat. I don't think I've ever melted through any of these rubber pads, but you can also get yeah, and it's fully articulating. So I usually like to, as you notice, I'm sitting really low, and that's for my neck and my back, because just like sitting at a computer all day, you don't want to be like this because it'll really fuck up your shoulders and your neck and your back. So I try to keep as close to eye level with the soldering station. That's kind of hard to do in a lot of situations, but in an ideal environment, that's what you want to have going on. Let's see what's next. We got iron here. Next would be wire strippers. These aren't the best. I think I'm gonna actually buy another pair because these are kind of wearing down on me. But yeah, this is a 22 to 32 gauge. Kind of hard to see. So that should cover pretty much anything that's in these little power cables that are pulling like an amp. I don't think you guys will typically be pulling too much more than that, but you guys let me know because basically you'll just want to go up in your gauges of wire the more amperage draw that you're gonna need from the cable. Wire cutters. These are the really nice, good ones. This is the most expensive thing in my whole kit. It's $80, but they're really, really nice, and I don't expect them to ever be replaced. Those things will last forever. Let's see. Everyone's favorite, flux, the secret weapon for all cup soldering.
Hey, do you buy solder with flux inside of it, or do you just?
Yes. You also want to make sure that the solder you have also has flux inside of it. Basically, the more flux, the better. Everything should have flux. And yeah, if it leaves a lot of residue, it's really easy to clean off, especially if you get the right type. They do make lead-free solder, which is less toxic, but I find that it's a lot harder to work with. It doesn't melt nearly as easily. So. That. You'll need some needle nose pliers for these stubborn collets, back caps, strain reliefs, etc. I really need to get another pair of the Nipex needle nose I used to have at Keslow, but that'll be for now. I like to have two types of tweezers, blunt tweezers for larger applications, and then the like sharp, really fine point tweezers. And this is really helpful for getting stubborn shrink tubing where you want it. And yeah, just get everything generally where it needs to be. You will need a torch or a lighter. This thing works sometimes, but I always keep a lighter just in case it decides to not work. I've got a nice, like, I think it's called like a micro torch or something off Amazon. That's a much nicer model. that I would recommend if you're going to be doing stuff like this a lot, or you just need like a really, really reliable constant heat source that is not an open flame.
And is that for melting shrink tube or anything else?
No, just shrink tubing. So yeah, I pretty much exclusively just use it for shrink tubing. And yeah, I mean, we'll get into this later, but you want to make sure that the heat, just like with the soldering iron, the heat from the torch is on there as little as possible. So you just want it to shrink because it will burn. It will burn really fast, and then it'll start to burn the plastic around your copper wires and the rubber and everything, including the plastic that the connector sits in. You need a razor blade. Try to use something else, but this thing is just so useful for a lot of things regarding cup soldering, mostly to do with you know, stripping the cable, the outer sheath of the cable, and cutting shrink tubing to size, because you want a nice like linear cut. You don't want to have to cut through it multiple times, because it won't lay flat on the pin, and then you'll have an exposed contact, and you don't want that. Let's see. Shrink tubing, lots and lots of shrink tubing. This was the stash that I borrowed from Keslow when I left. It's running pretty low, so I got this assorted, I think it's like a 45 piece, multi-pack from McMaster-Carr. This thing's got everything. Very happy to have that. Super cheap, well, pretty cheap. You want to get typically the black stuff it's thinner as far as the thickness is concerned, and then it's also has a higher shrink ratio. This white stuff, it technically does shrink, but not very much.
You talk about shrink ratio real quick?
I would say
it's something when people are shopping for shrink tube, there's some shrink tube that go to like 2-to-1, 3-to-1, 4-to-1. So like if it's 1 inch, which would be huge, it would shrink 4 times down. So it's helpful if you need to get shrink tube over a big connector and then apply heat, it will shrink down 4 times the size, etc.
Yeah, I think that would be good in very specific applications. I find the most widely available, which I'm assuming is 2-to-1, is fine for most of my applications. It's really like the thickness of the shrink tubing, because when you've got it, let's say that you're making like a Preston motor cable and you've got literally 8 pins and they all need shrink tubing. You want the thinnest thickness of shrink tubing just so you have room to move it around and actually like get it down once you've soldered the connection, because it gets really crowded in there. But the higher shrink ratios would probably be good for things like wide cables, when you really want you want it to go over everything while you're prepping, but the actual connection is really small, so you want it to shrink down really small once you're ready to apply the shrink tubing. I always keep electrical tape around just in case. It's never a bad idea to have. Like if you've done like a really nice connection, but like the shrink tubing was just like a hair, not too short, but like you can see that over time it might come out. I usually just like double over that connection with electrical tape, you can never be too safe. But you always want to ideally, at least when you finish the connector, have the shrink tubing cover both the pin and the stripped wire completely. Jeweler screwdriver, and this is for the P-tap connector. And then I also made a speak-on cable for Tyler yesterday, and I used this as well. And then probably the most important thing, your multimeter. Because I'll go over this a lot, but you're going to want to check continuity after assembling every single cable. You might even want to do it when you're just starting out, after every single end of the cable. So like you do one connected end and then just test it against the bare wires of the other end. But definitely after every cable is assembled, you want to check continuity. If you have a power supply, you should also check power. And my favorite fashion statement. These things are awesome and they're cheap. Well, the McMaster ones aren't cheap, but there's from the Carlos class, I think I found some on Amazon that were pretty cheap. I don't know about their quality, and I think you can also get different size lenses, like if you want a different magnification. I believe this gives you like a 6-inch working space. But yeah, right here is about as close as this magnifying glass would get. So it's just, you're really able to really QC what you're working on. Make sure that it's right. And you don't have to just like hope that it's good. And then I think, oh, the desoldering braid. This might have helped Ryan with his PCB removal of the solder so it didn't burn so much. But there's lots of different things out there besides the braid. There's pumps, which basically you put the soldering iron to the solder you want to remove, but you also put the pump. And then when it gets hot, you like release the pump. That thing is hard to work with. I'm not a fan. They also have vacuums, like desoldering vacuums with heated tips. So it's kind of like the pump, but the point of the pump that reaches the soldering joint is heated. So it melts the solder and then it vacuums up. It's powered though. So that's a much bigger device, but that thing works great. I think that's it for the tools.
Awesome. Does anyone have any questions?
Yeah. Questions?
I know Ben said that the glasses that you had, they make ones with lights built into them too, so it helps.
Yeah, the
really
one
close.
that I put on Amazon has a light on it.
Yeah.
I've been using this little guy as my light source. Cool.
If no one has questions, I think we can move on to the first demo.
Well, first let's talk about the cable.
All right.
Jamie's very excited to get to the demos. So yeah, most typically you'll probably use Mogami 2893. It's 4-conductor. It's very small. It's very pliable, which makes it really, really nice to work with. Again, the conductors are pretty small, so you don't want, ideally you don't want anything more than an amp going through it. Hopefully less. I actually combine the two. If I'm just making a power cable, I'll combine the 4 wires into 2 wires just to like make the gauge thicker, basically. That's like a trick to making a thicker gauge out of a thinner gauge.
What was the cable called again?
Mogami 2893.
2893, got it.
Pretty much, I think Keslow used this for the longest time. I think they've since gone over to a 7-conductor cable to make the connections even thicker, to like combine even more conductors just to protect against even more amperage needing through it. Because the thing is, when you make a cable, you make it for a specific function, but if like, I don't know, someone in the camera department needs to borrow a 2-pin to P-tap, like you don't know what they're going to plug it into. So you want to protect it against, you know, the most amperage draw device that the department would use that has that connector. The other gauge that I like to use is this Canary, what is it, L4 E6S. And it's just got thicker conductors. So I used to use these, we used to use these for like little battery plates that we would make. So we just make like a V-mount battery plate or something, and then have like a Steadicam or something, you know, for Steadicam jumpers, things like that. Basically, the more amperage, the thicker the conductor you want. Just always go for the thickest that you can get that will still fit in the cup. If you go too thick, I think I had to do, I can't remember what the gauge was, maybe Tyler remembers, I had to do this XLR cable for him for his inverter. And the gauge of the cable was so thick that I literally had to trim the tip of the, the copper wire that was going to go in the cup, because the wire was thicker than the pin on the XLR. So it just wasn't even going to go in there without some finagling. But yeah, I really like this Canary L4 E6S for like things that could power like a camera or a monitor, things like that. Ideally not a camera. Well, that's tough. We've always had trouble with making power cables. Well, we didn't always have trouble, but it's always been like a back and forth finding the right power cable for cameras, because honestly, the amount of amperage that these cameras can draw these days, especially with all the accessories plugged in, it's really hard to find cable with conductors that are still small enough to fit on these pins. Like really, you want a gauge of cable as thick as you could possibly get. But you're limited by the size of the connector at the end. So that's another problem that as digital cameras have become more prevalent, is that everyone still wants to use like this 2-pin, but the connection is so small that you can only get, you can only get specific sizes to even fit in the pin. So you just kind of have to, not trial and error, but just do the best with what you got, I guess. Yeah. So that was, oh yeah, I like to use stranded cable, or stranded conductor cable versus solid core, because the solder gets into the copper a lot easier. And it also makes it a lot easier when you need to do things like make a Y cable, because you can twist the strands together. You can't really do that with solid core. Doesn't work so well.
Does anyone have any questions while Melissa's talking about all this?
So I'm not able to read the chat. So if you see something in the chat, Jamie,
yeah,
let me know.
We'll put together like a parts list of what she's talking about as well, guys, so you can see the cable and the tools, all for later reference.
Yeah, I think it is also in the parts list from Carlos's class. I think it's the same parts list, because I made that parts list. So it should cover everything you need. It's a different soldering iron than I've used, but there's so many options out there that as long as you don't go the cheapest, and it's not one of those AC powered ones where it's literally just the iron and an OSHA plug at the end, then you're already in better shape. All right, I just want to show you the stranded. I don't have any solid core because I just don't recommend solid core for soldering, cut soldering. This might be tough to see.
Yeah, the solid wire tends to fatigue crack pretty quickly too, so that's a pretty good reason not to use any solid wire for any of this stuff, because it just doesn't deal with a whole lot of vibration and bending before it just breaks.
That makes sense. But yeah. I think that's all of that. I think that's all. Prepping the cable for soldering. Yeah. I think that's all I have for that segment.
Cool. Any questions, anybody? Feel free to ask away. We're just in the basics right now, just getting like preparing to start doing the first cable in essence. So the next thing would be 2-pin LEMO, right? You want to show your screen?
Yeah, if you guys are ready. I pre-recorded close-up of me assembling most of the connectors just for time constraints sake.
We have a good question. What application does solid wire excel at over stranded?
I don't know. Carlos, do you have
Yeah, when it's going to be completely restrained and never moved and needs to carry a lot of current relative to its size.
that
So
makes sense.
the solid wire can be physically smaller. You don't have the air gaps between the strands. But I only use it when it's in a completely like movement restricted, vibration isolated kind of environment. Like even like internal wiring on most mobile devices, most of those use stranded wire because they'll be subject to movement and all that kind of thing. So, you know, I've got one spool of solid wire for every 50 spools of stranded wire. Tell you how much I use it anyway.
Yeah, the only time I've used it is to make personal cables. Never used it at Keslow because it's not really useful for the amount of wear and tear that a camera department puts on a cable.
Yeah.
Yeah, and the camera department's pretty good at putting wear and tear on everything.
Yes,
That's what we do.
So yeah, I pre-recorded these cable assembly videos so I can stop it, rewind it, you know, we can just go over it multiple times. And I will do the XLR connector live though, so you will get to see it in real time. Yeah, this is the first one. This is the 2-pin LEMO. One second. So yeah, there's a shell, and then there's these 2 half pieces that fit together really, really nicely. Like you'll know when they're put together properly because they'll snap into place. There's a little, where is it? Yeah, there's a little, do you see my mouse?
Yep.
There's this little raised piece of plastic on the pins itself, and that's where that will fit in really nicely right there. And that pretty much lays it out for the rest of the connector to go together. Is that little.
Correct me if I'm wrong, but that also technically points at the hot pin, right? So that when you're assembling this, you want to make sure that the pin that's hot is facing with the red dot, if you will.
Yeah, there's also, and I think I'll show it better a little later. I think it's further in this video. There's a little white semicircle. If you're looking straight down at the pins, there's a little white semicircle from the back side, not the front side. There's a little white semicircle that denotes the pin 1, which is actually your ground.
Got it.
So yeah, I scavenged this cable again from my stash at Keslow. The collet is really important. You can find all sorts of this exact connector with different kinds of collets. And it's the last 2 numbers in the part number for the LEMO connector. So it's like FGG 2B clad 52, something like that. 52 is 5.2, and that's the diameter of the final cable that you'll go over. I was trying to do this in the YouTube series of soldering with another 2-pin that was donated to me, but the collet was 42, and I didn't have any cable that was that diameter, so I wasn't able to use that connector. So make sure that you get the right collet, because even with, Fisher connectors as well, you have to order the collet separately, actually, with Fisher connectors. So there's many different collet options available for the same exact connector. So that's something that can get in the way of your soldering really quickly. So yeah, can you see that semicircle right there?
Yep.
So yeah, that denotes pin 1 on LEMO connectors. And on connectors that are more than 2 pins, you'll actually see the white semicircle will go around pin 1, and then the white line will trace around the connector in the direction that the pins go. So it'll be like 1, 2, 3, 4, 5, 6, etc. And it won't be a complete circle, and that's how you'll know what the So yeah, prepping the cable, you want to use your razor blade. You're using shielded cable, which is very, very helpful in multiple ways. First of which is that you won't cut through in rubber part. So yeah, when you're stripping the cable, or the conductors rather, you want to make sure that the part that you're stripping reaches all the way to the bottom of the cup. So you might pre-measure that more, that the stripped part goes all the way to the bottom of the cup and not past the cup. You don't want too much stripped, because then you'll need longer shrink tubing, and the coating on the copper is just another piece of protection against wear and tear. So here, even though I'm doing a power cable, I'm cutting all 4 wires. There's a loud car. I'm cutting all 4 wires because I'm going to turn them into 2 conductors, allowing more amperage pull. So yeah, and then I said this in the YouTube series, but just for, what do you call it? A standard, just to make it a standard. Black should always be ground. So if I'm doing these multiple conductors into one conductor, I do the black and the clear as the ground, and then the colors as the voltage. Yeah, black is ground, any other color is voltage. If you don't have black, chances are you'll have like a white or a clear, and I'd make that the ground. So it's just good practice to always make like colors, voltage, and lack of colors, or black and white, ground.
So just to cover what you're doing right here, you have 4 cables, or 4 individual cables inside of this one, but you only need 2 connections. So you're grouping 2 cables together, and theoretically that buys you a higher amp pull, draw if you needed it.
Yeah,
right?
You're basically like cheating a higher gauge of cable.
Right. Could you just snip off, if you're making like a low amp cable, for a device or something like that, you could just snip off the white and the blue and just use red and black?
Sure.
Yeah.
But again, I always do it this way, just in case someone borrows my cable and plugs it into something that I didn't design the cable for.
Fair point.
That's my flux. I always like to apply flux and solder to the pin, to the conductors, and to the cups themselves. It just makes, there's a lot of steps that just make the flow of the solder a bit easier, and I find this helps make the solder flow faster and easier. And the less time the soldering iron has to touch any of your connections, the safer all your connections will be from overheating.
There was a question about you use the razor blade just to strip the black outer plastic shell, right? And then you use the wire strippers to strip the colored wires on the inside. Is that right?
Yes, that's correct.
Yeah.
I wouldn't use the razor blade for stripping the conductors themselves because the copper inside is very soft. You'll very easily just cut right through it with this razor blade if you're not careful enough. And the wire strippers are designed specifically to not cut into the copper and just cut the colored shielding.
That's the beauty of the wire strippers. You could just press down and pull away. You know it's not cutting your wire if you have it set to the right size.
Exactly. There you go. Just like the flux makes it so easy, you literally just touch it for not even a second.
Would you mind rewinding just so people can see that?
Got it.
Yeah.
And I've got lots more of this type of stuff too for the other connectors. So this will not be the last time you see solder applied.
Yeah.
But
and
you
so
see,
just so
even
everyone knows you've tinned the tip of your soldering iron already, right?
I didn't actually, but you can see the solder is right there coming out of the top. So this is the solder. But I tinned the conductors with flux, if that's what you mean. So I put flux on the bare copper, and then I take the solder. You could also just put the solder to the iron and then put the iron to the conductors. Like it's 6 in one, half a dozen in the other. That's not a big difference. It's really just what you're more comfortable with. But yeah, you see even that like half a second, you can see it's already starting to melt the rubber shielding. Or I don't even know what this material is, actually. I doubt it's rubber. Maybe it's rubber. Yeah, the insulation.
Plastic
like it's
insulation,
already
yeah.
starting to, so the less time you have the soldering iron to any of your components, the better off you'll be.
And just a tip for people that are starting too, if you have shrink tube over, let's say like the white and the black, and it's, if you're not using flux, the amount of time the iron, has to sit on the wire to get hot enough for the solder to melt the heat can start traveling up the wire and start to melt your shrink tube. Happens all the time. And then there's a race to like move the shrink tube as it's shrinking over your connections. And it's just like, if you use flux, you avoid all that.
Yeah. You'll also develop some really nice calluses on your 2 fingers that hold the shrink tubing up, just from the heat, the like residual heat coming off the iron. So I don't solder as much as I did before, but I used to have some pretty serious calluses on those fingers. And then you put on the back cap. This is all before you solder the conductors to the pins. You want to put on the back cap and you want to put on the collet. Do not forget this part. If you forget this part and there's a connector on the other end, then you've soldered the pins for no reason, because you have to unsolder them, put the back cap and the collet on, and then resolder them. So don't forget, put the back cap and the collet on first. And you will forget. I forget all the time, even though I've been doing it for a very long time. It'll just give you more practice.
So right now what you're showing us is you're kind of building the cable backwards once you have those connections soldered together. Because once you connect this, you won't be able to get the collet on there or the sleeve, right?
Exactly. Like the pins are married to the cable, and you won't be able to get the back cap over the pins. You won't be able to get the collet over the pins. So you have to put it on before you attach the pins to the cable. So this is called, I believe it's called a preform, a solder preform. So basically, this is something that I learned in that Omni training. You put the solder in the cup, you cut it off, and then you touch the iron to the cup and it melts it and fills the cup. That way, you've already got some solder in the cup, you've got some solder on your conductors, so you shouldn't need much solder, if any, when you're actually attaching the conductors and the pins, because you've already got both ends pre-tinned with solder.
Super simple.
Yeah, and if you've got a cup that's bigger than your solder, you just twist it. You can't really, and it'll still fit in the pin. Like for this, to get it to fill the cup. And you just put it in there and you chop it off and you add the iron.
How do you make sure you don't fill the cup with hardened solder?
Well, solder can always be softened with heat. Then that's why you're able to use things like the desoldering braid and the pump and the vacuum, is because as long as you apply heat, 750 degrees of heat, you can get that solder to be soft again.
Does that make sense, Ben?
Yeah, it does. Yeah, you can suck it out, but you've still tinned the inside of the cup, so you're good, right?
Yeah. Mm-hmm.
Yeah, and she was showing a great little tip where you can actually stick the solder into the cup and then you just snip it right at the top. So when you melt it, it just starts to collapse inside the cup and now you have solder waiting for you inside there. It's a great little tip.
I missed the little clipping it. Right.
Yeah, there it is.
That's the perfect amount so that you don't fill it, but you just wet the insides. Okay, got it.
Exactly. So
that's a great little tip right there.
Yeah, this is a good point to talk about what Jamie was talking about, which is the shrink tubing. So you can use a shrink tubing that will just fit over your wires. I don't know if you can tell, that shrink tubing was pretty tight on the wires. But if you, it doesn't protect you against pre-shrinkage, as I like to say. So the iron is gonna give you some residual heat along the cable, no matter what, no matter how long it's on it. So if you use a slightly bigger shrink tubing than the conductors, then you protect yourself against that shrinking before you want it to go down. So you just give yourself a little more wiggle room to actually be able to move the shrink tubing over the pin when you want it to, and not have it accidentally shrink onto the insulation. But even if you do that, as long as it's not like completely like clamped shut on the shrink tubing, you can use these lovely little precision tweezers to like kind of encourage the shrink tubing down. But I always like to try to go one size bigger on the shrink tubing if I have the space, which I do on this 2-pin, versus using the perfect size, just because it protects you against it shrinking too much before you're ready to put it on the connection.
So right here, you're about to start connecting the cable to the thing, the head, right?
Yes. And ideally, you want to be able to push the copper into the cup as the solder heats up. And this is another point where the magnifiers come in really handy, because you can see when the solder melts. So you know when to do that gentle push to get the copper into the cup. Because if it just touches the cup, it still could be a good solder connection, but a better solder connection is to get it all the way to the bottom of the cup. It's just longevity. It's just really how long do you want your cable to last? Because solder joints, especially with cables, will eventually break, especially when used by camera departments on set.
Are there any questions as we're watching this, guys? Feel free to chime in and ask away.
Yeah, maybe I missed something, but you tinned your wires, and then you did the what you call the pre-solder.
Preform.
Preform, thank you, in the cup. And then once that, firmed up, was that the only solder that was being used to make the final connection?
It can be.
Was that what you showed in your video, is that you just applied the iron again while putting the wire into the cup and it melted everything and then cooled off and made the connection? Or did you actually apply some more solder at that point?
So for the initial connection of the pin and the conductors, I just used the iron because it basically reheated the solder in the cup, which traveled up the conductor to marry the two. But using my magnifiers, I noticed that the wetting, which is the term for the best connection of two different joints into one via solder, was not the best. It was good, but it could have been better. So I did add just a tiny bit more solder after that initial connection, just to make it super, super solid. But that is just every time you do it, it'll be different. Like sometimes you will, sometimes you won't. Sometimes you'll end up adding too much solder and you'll end up with this like bulging piece of solder on the pin and the connection, and you won't even be able to get the shrink tubing down. That's when you'll need to desolder and do it again. So it's just really, it's never going to be perfect every time. You're going to have to just really know what you're looking for. And I found a video on YouTube that's a really nice close-up and explanation of good wetting. So I'll post that in a bit. Yeah, it's just the more you do it, the more you'll be able to tell what good wetting is versus bad wetting. A nice test I like to do is to literally try to break the connection. Not like, break it in half, but literally like jiggle it back and forth. If you get any sort of movement, you need more solder or you need to desolder and resolder. So it should be super, super solid as one connection. The way I do it, and I think I'll show you here in the video, is I literally lift the vise up by the cable connection. And that's my little not precise test to see how good it is.
I think it's good to cover that, because if it breaks, then you're saving yourself from having to fix it once you hand it off or put it into service. So break it at your station as opposed to out in the field.
Break it while you got your soldering iron out.
Yeah,
and
exactly.
You got all the tools right in front of you. So yeah, now I'm reassembling the 2-pin. So I've got sorry, my big fat fingers are in the way. It's really hard to do these tiny cables without my fingers getting in the way. But
can you talk about wetting real quick? And are you saying wetting with 2 T's or wetting like DD?
Yes, I am saying wetting with 2 T's. Let me find, I have it.
And then it's like making it liquid, right? It's right. Is that what that's kind of describing?
It kind of looks like you can't tell where the pin ends and the conductor begins. Like it just looks like one solid piece of metal. But
do you have a good frame grab or still frame of that?
Well, here, it's a YouTube video, actually. But oops, let me put it in the Zoom chat.
Now there's another question. Have you ever first inserted the wire into bare cups and then add or solder as the last step?
No, I mean, I did when I was first starting out, and I didn't have, a lot of experience doing the soldering, but the training, the Omni training, like really, really opened my eyes to a much more efficient way of soldering. So doing it this way ended up having a lot less mess soldering and a lot less time with the iron to connection. So a lot less burned components, things like that.
It's so much easier to slide the I guess the copper parts of your cable into the cups when they're soldered that's melted and hot. You just slide it in, pull the iron away, and then it just cools instantly. As opposed to trying to get solder to flow into the cups along a cable. It's a little more sloppy that way.
Here, let me post this YouTube link.
And then Ben's asking, how do you get flux down into the pins with that felt pen or cups? Yeah.
Well, I actually haven't been, sometimes I do it that way and sometimes I don't. You just do it like that. You don't need a lot, like a little dab will do you. And you won't even really see it go in there, but it's doing something. I find that if you use the preform, which is putting the solder in the cup, cutting the solder off, and then putting the iron to the cup and letting it melt, since the solder itself has flux in it, that pretty much takes care of the solder and the flux in the cup.
Got it.
Yeah, if someone finds a frame grab of that YouTube, sorry, I didn't grab the frame grab, but I think it's like halfway into the video. There's a really nice comparison of good wetting and bad wetting and acceptable wetting, etc.
Cool.
Back resolve. Here. Oh no, did it start over? No, it's here. Okay. Yeah, now I'm reassembling the 2-pin LEMO. So you start with the side piece that has the little keyway, so it matches with that plastic raised groove on the pins. The back on, it should snap on really, really nicely if you've got it all lined up. If it doesn't snap on, don't try to force it.
Hey, Melissa, we can't see the video.
Sharing is paused. Bring your shared window to the front. Apologies. Bring your shared window to the front. Share screen. Here. That's what it was. That's what's going on. Technology. Let's try that. You see it now? No. Bring your shared window to the front. I don't know what that means. I don't know how I'm not doing that. Here, let's.
It's okay. Anyone have any questions while we work on this? I guess there were comments about using a flux syringe if you really want to get flux down into like a cup really deep. But Carlos, do you have any comments on that?
Yeah.
Is that even super necessary?
I mean, my technique is, and I'm not saying this is necessarily right or wrong. I use the flux syringe with a really fine needle, and I put a drop of flux at the very bottom of the cups, and then I'll put some flux onto the to the wire, the conductors, whatever's going to go in there, and put all of that together with no solder at all, and then I solder it after the fact. And the reason I kind of stuck with that technique is because when I had the preformed cups and or just solder in the cups, whatever, I never use that term, but the wires tend, sometimes when I'm pushing this thing in there, if it kind of split the conductors and the thing kind of started going everywhere, at that point, I'm in a big rush because everything is hot. And that little strand that kind of shot off to the side is kind of hard to manage once you've got the solder melted and all that. So I kind of get everything together and I confirm that it was all neat, but everything is completely covered in flux at that point. And I just take a drop of solder and do it at the very end. So I'm guaranteed not to get any flyaway wires. You know, is that something that would pass the IPC soldering standards in an international soldering competition? I'm not entirely sure, but at least I have a reason. Take it or leave it.
Yeah, I do think that there's more than one way to solder. And you'll just have to find the method that works best for you and the way you like to solder. But both of those, the way that I do it and the way that Carlos described doing it, both should result in good wetting. So,
yeah, as long as you've got the flux in there, that's the big thing. You can't have bare copper and just like take solder to it, because the solder is just going to sit on top of the copper. It'll never wet. It'll never flow through without that. So the flux syringes are pretty cheap, and you can get the needles from McMaster Carr in every imaginable size, and then you can have really at least precision application of the flux without getting too much or too little.
Yeah, I don't really like this pen for what I use it for. It might be okay for like PCP or something, but yeah, I did buy a new supply of flux, and I got it in the syringe. So I'm looking forward to using that again. So yeah, you guys can see my screen now, right?
Yep.
Great. Sorry about that. So yeah, reassembling the 2-pin, you want to get the one side piece on the plastic raised groove of the pins, and then the rest should fit nicely together. You put the back cap on. Yeah, so you put the back side piece on, and it should snap into place. If it doesn't snap into place, do not force it, because it means it's telling you something. It's telling me I'm not right. Please don't put me together. If you do try to put it together and you somehow are able to put the whole connector together, you could possibly end up with reversed pins, and you could short out whatever device you're plugging it into. So
that's
just make
super
sure
common on the counterfeit Limo connectors. They kind of miss this locking connector. So like if you get a 2-pin Limo that rotates, don't use it, because you'll never know what orientation the cable was supposed to be in.
And I won't show you just like this correct, but even on the regular 2-pin Limo, you can easily move the whole thing and reverse the keyway. Just the shell. You can just literally twist it and it'll snap into a different spot, but your cable will be backwards. The voltage will be reversed. So you just got to be gentle with these tiny connections. Never like yank on it or twist it. Don't put a lot of muscle behind it, because these are very fragile pieces, as you'll learn as you start to solder them. So yeah, then you match the side piece tooth with the collet. And then again, when you're putting the shell on, you twist it gently until it basically goes down and meets the collet. And if it doesn't do that, then it's not ready to be assembled fully. You just got to keep like taking it apart and putting it back together until everything fits well. If it doesn't, you might need to check your solder connections. Maybe the wires that you put in bulged out too much, and now the side pieces won't fit snugly because the solder connections inside have like bulged out and won't allow the space needed. There's not a lot of tolerance for these pieces. So it's just precise, do it right the first time. Don't close up the connector until it's done right.
I think for anybody that's trying to learn how to solder, that definitely spend some time at home making mistakes and trying different methods before you try and do this in the field, because then you're going to add pressure and like time plus expectations onto your skills. So just take your time, get it confident at home before you start offering this up to fix cables on set.
Yeah, that's a very fair comment, and perhaps starting with Limo is maybe a little bit more challenging than starting with XLRs or something that's bigger. The XLRs are quite a bit more forgiving.
If you want to do a P-tap, you can. The pins are certainly easier, but the assembly is a lot harder. But I have a trick for that as well. So when we get to that, I will talk more about that as well. So that's pretty much the 2-pin LEMO connector.
Any questions about that, guys?
Well, the last step that I did not put in the video is once you've assembled that connector, test continuity. Always, always, always test continuity.
What does that mean?
Here, if I can show you. Basically, we got this lovely 2-pin. You know what? Actually, I'm going to undo this because I can put it back together pretty easily. I'm just going to expose the pins.
It's fine. You can just talk about it too.
Well, I feel like it'll be easier for people to visualize if I actually show it. But yeah, basically you take your multimeter and you want to test that the ground on one side equals the ground on the other side. So you haven't accidentally reversed voltage on one side and basically sabotaged your cable. Because no matter how many years you've been doing it, I would never skip this step. I would never recommend skipping this step.
This is the trust but verify part of the cable making and soldering. You're basically making sure that the cable that, you know, the connection that should be positive stays positive all the way through the tip of the connector.
I would just add, certainly if you're doing repairs on set, this is a critical step, because in the hustle and bustle of being on set, you could easily just like, oh, accidentally, you know, solder to the wrong pin. And then if you don't check yourself, you could blow up your tear deck or whatever.
You're gonna wreck yourself.
Yeah.
You could especially do it if whoever assembled the cable before you didn't go by that black equals ground,
Yep.
red equals voltage. I've definitely run into that where I've repaired one end of a cable, just assuming that they wired the other end with black as ground and red as voltage, only to test continuity and find that they had decided to not do that. So I ended up crossing voltage on the repaired end and had to redo it. But yeah. So yeah,
sometimes you have to reverse engineer a cable if it didn't come from like a manufacturer. If someone made it, just take the time to understand what they were doing if you have to use that cable to repair it, because I've seen some funky stuff. Electrons are colorblind. There you go.
Yeah, I'm on the negative pin on the P-tap, and I'm on the pin 1 on the 2-pin LEMO, and that should be ground. Negative, at least for all our intents and purposes, means ground. So you'll see a lot of connectors that just say plus and minus. Plus will be voltage, minus will be ground. So yeah. I think that's it for that. Does anybody have any questions about assembling a 2-pin LEMO?
Doesn't seem like it.
Okay.
Let's show the most loved connector, the P-tap. The one that we almost didn't want to show.
Yeah. I tried to fight hard on doing this, but it needs to be done. It is the most common, especially for personal gear.
Yeah.
So are you able to cover real quick how you were able to determine the strip length on those LEMO connectors, like, you know, where you strip the jacket back and how long the conductors were coming out of there and all those kinds of things? Because that's an area where I've kind of got myself into trouble. I get it all soldered and it looks great, and then I try to slip the thing over there and the collet's not in the right spot.
That's
on your technique for that.
That's mostly just experience, because these are the only connectors that I've been doing for the past 7 years. So it's just because of that. But what I would suggest is that you do it too short first, the stripping of the black part. So do it too short. Then try to maybe pre-assemble it without soldering anything. Just like have the bare wires in there and see how everything fits together. And if you see that it's too short, then cut it back longer, because it's a lot easier. I mean, depending how long your cable is, if you pre-measured it and stuff, it's a lot easier to cut more away than to cut less away, especially if you're repairing a cable or it's got to be a very specific length. What is a good? I don't know. Let's see. I usually start with maybe 3/4 of an inch, maybe a little less. As far as the black jacket goes, I usually take that off, and then maybe like 1/8 of an inch is for the wire strip. But again, for that, you can just test the cup. You can just put the copper into the cup, and if you see copper coming out the top of the cup, that means it's too long. You need to trim it. So you just want the copper to be in the cup and not go past the top of the cup.
Makes sense.
Yeah. Measure twice, cut once, blah, blah, blah. Yeah. I think, yeah, if nobody has any questions, yeah, let me set up the.
I feel like the P-tap connector is like PSF for video.
Yeah.
Just needs to go.
It does
away.
work. It's a really solid connector, and I like that. Well, I have seen people plug it in the wrong way, but it is designed to not be plugged in the wrong way because it's got that like curved side and then the flat side. So again, if you're not trying to force it, it's generally pretty easy to tell when it's going in backwards. So that is one thing I do like about it. And it's a pretty sturdy connector. The way that the housing is designed, it keeps the pins pretty safe from wear and tear. The only part that starts to wear is the part that comes out of the connector. So there are some things I like about it. Assembling it, not so much. So what I'm doing right now in the video is I am using the shielding and that's because P-tap is usually going into a power source. So the power source end of your cable, you want to put the metal shielding that is just inside the black insulation. You want to attach that to your ground wire into the whatever pin your ground is. And that's to prevent, I believe it's called a feedback loop. Is that correct, Carlos? Is that the term?
Yeah, a current loop. Yeah.
Current loop.
Yeah.
But yeah, it's basically just to protect against, current going where you don't want it to go. More of my fat fingers. Yeah, do the same thing, only this time I've got 3 attached to the ground instead of 2. I've got the shielding, the clear and the black, which are going to be my ground conductor, and then I've got the red and the blue as my voltage. Applying the flux. Again, you don't need that much, just a little bit. So yeah, you kind of want to do it until you see less of the strands. That's why another reason why I like the stranded wire is because you can tell you got good coverage of solder when you can't see each individual strand as well. Because it's been like, I don't know, it's been covered by an adequate amount of solder. It
looks like one cable, yeah.
Yeah. Yeah, this one I did put the flux in the pin, and I did the preform. So there's some number of ways to do it.
Did you coil up the solder because it's a bigger hole? Is that what
Yes.
I saw there?
Yeah, because you want to. Yeah, because you want to try to fill the hole with as much solder as will fit.
So you twisted it.
Yeah, twisting it allows more solder. to get in there than just like folding it in half.
Sweet.
And yeah, this is a little different because there's no, you know, chassis that the pins sit in. Because of the way that the connector is assembled, you don't really need shrink tubing. You could add it if you want, but basically you've got the pin, you've got the conductor, the copper going all the way into the pin, so there's no exposed wire. And then I do it again. Here, I'll go back and show you that one time.
Did you talk about how one cable has to be a tiny bit shorter than the other one for PTAP because you're making a 90-degree turn?
I haven't found that to be the case.
Oh, really?
Personally. Yeah, you just want to make sure.
It's in the manual for the PTAP connector.
Is it really?
It is.
I've just never had to actually do that.
It's a very small cut. I think it's like a 1/4 inch or an 1/8 inch or something like that. But the bottom one has to be a little bit shorter than the top one, and that helps make the bend and keep them cleaner.
I've always found there's enough room inside the connector housing just to loop it in there.
Yeah, I've actually seen. I opened one and there was like an actual loop, and I was like, "Jeez."
Yeah, there's my test, my good solder joint test, lifting it with the vise.
Yeah.
So yeah, these are the same size. The stripped wire. And yeah, as long as there's not too much room or too little room, I find that there's enough room to just
mash it in there.
It fits pretty nicely. There is enough room, I find. It does get a little, you know, bendy. Okay, so if you've ever tried to assemble a PTAP connector before, there's this little metal tab.
Let me see.
That is strain relief. Can you guys see that?
Yeah, we can see it now.
Yeah. So this metal tab is garbage. Throw it away. Do not use it. What we started using at Keslow was very tiny zip ties. And it fits so nicely. It fits really nicely in that little channel, a lot better than the metal tab would. So you basically just get the right size zip tie. Unfortunately, I don't know off the top of my head. I didn't have any on hand when I was assembling this connector, which is why I'm showing you on the video on a chopped connector instead of the one that I'm building. But it fits really nicely in there, and you just zip it, and the little the clamp of the tie fits in perfectly in the space next to the cable, and it squeezes the cable up against the side, creating even more strain relief than the metal.
Sweet.
Too small for Ogami 2893, so it doesn't even fit around the whole cable properly. Like you end up just like biting into the cable with the strain relief, and that's just one of the many parts of the nightmare of dealing with that metal tab. So I would definitely recommend just not using the metal tab. If you really, really want to know how to use it properly, there is tricks to it, but I'd rather not cover it because I just want you to not have to use it at all.
Copy that.
They're so much easier to deal with because most of the time assembling the PTAP connector is dealing with that fucking metal tab. So yeah, this works really nice if you have it on hand. The two types of zip ties I have on hand currently do not fit in the PTAP, so I'm gonna go pick some up at Pack Radio once this is all over.
Sweet.
So yeah, then you put in this lovely little, call it a stopper. So basically you can put the cable through either side. You can put the cable through the left side of the connector or the right side of the connector. It gives you that option. But whatever option you don't choose, you got to put this little black piece over it so there's just not like a big hole in the side of the connector. And you put the top on, you got to make sure that it's flush. If it's not flush, then most likely what happened is that one of your pins is not set flush. The pins have like a little hexagon on them, and the connector itself has matching hexagon cutouts as well. So if they're not all perfectly lined up and flat, you won't get a good seam.
Hey, would you go back to the image where you can see the cable open, and you just, yeah, like just want to point out, like right there, when Melissa was saying that you don't technically need shrink tube for this kind of connector, it is true, but you always want to make sure that if you have bare copper, like you do right there, it's not touching the other connector, because the braided can fray. And so even one little strand that comes off of that touches the other connector will cause a short, right? You just want to make sure that if there's bare copper, it's never going to touch something that it shouldn't.
Yeah, and in this case, it might be tough to do shrink tubing because there might not be any working room.
You could use super glue, not super glue, glue stick.
Yes, you can also use liquid electrical tape.
Yeah.
Or regular electrical tape. So that is a good point. So yeah, you want a good clean seam, and then you push in. There's this tiny little back nut. You hold it in place, flip it over, put the screw in, and with a tiny little Phillips, you just screw it in there until it's tight. And that's it. That's the whole thing.
Any questions, guys? If not, we'll move on to the live demo.
This is Ben. I have a question that I put in the chat, but I just wanted to, I'm trying to get a better sense of the science behind taking the shielding and tying it in with the negative side, because on the other end, that just gets clipped off and left in the wire, or?
That's purposeful, yes. You only want, Carlos just responded, you're only supposed to put the shielding on the power source end.
And so that actually is dampening certain kind of electrical noise, even though it's just connected on one end and running down the cable.
It's like a protection. I have a document for that too, actually.
Okay, I will take your word for it.
No, I wanted to try to get more together as well. But this talks about using an additional ground for the power source end as well. Just for the technical jargon people. I just do it through practice. A lot of these things I just learned how to do first and then learned why to do it afterwards.
Awesome. You want to work on, we can switch over to the live view and we'll show people the XLR connector next.
Yeah, is that next?
Yeah. Well, continuity, but we'll show that after you.
Oh, I was going to do the split cable. Did you want to show that, or you want to do the XLR first?
Let's do XLR.
Okay, cool. Yeah, also same thing with, you want to do the same thing with the P-tap as you did with your 2-pin, and that's check continuity. Check continuity. I'm not going to stop saying it. Check continuity. All right.
It takes seconds to check continuity, and it will save you so many headaches.
Well, let me get this going.
Yeah, one thing that you guys should remember too, if you start building up your soldering skills at home and whatnot, and you feel like you can build a little Pelican case, that you bring to set with you. If you're going to offer to solder other people's cables, you just want to have your confidence at a certain level and your knowledge before you start messing with people's personal cables, or even trying to fix like a cable that Panavision made that went bad. Pretty important. Just be diligent about checking yourself before you hand off a cable, because once you hand it to someone, they're going to assume that it's done properly, and if you have to ask for it back, you kind of start to lose their confidence in you. So just hand it off when you're ready is my piece of advice.
If you are going to repair a Panavision cable, be very careful. They reverse their voltages. So they usually do it, like 4 is, because on
a block battery, I think 4 is hot and 1 is negative.
Well, that's the typical, actually.
Oh, then it's backwards
so
on Panavision,
yeah. And Panavision, I believe, is the only ones that do that. So you definitely want to check continuity if you're repairing a Panavision cable on set, because they don't use the standard, and I think that's
it's labeled on their batteries too, though.
Yeah, and they do.
And then also another good tip, guys, if like usually special effects, props sometimes, but electrics, there's other departments on set that usually have soldering tools and kits just because they need to fix stuff. So if you're ever not without your soldering kit, you can always bug special effects or.
Oh yeah, I did. Oh, this would be a good time for this story. I have a story. So I was on a show, and we had one of those Panavision boxes that converted 24 volts to 12 volt because we had the camera on a crane, and we wanted the extra power because the cable length was so long. So as the cable length gets longer, I'm sure a lot of you know this, as the cable length gets longer, you get voltage drops. So if you have a 24 volt and then at the camera end, you can convert down to 12 volt, then you have less of a voltage drop. But basically the cable going from the battery into that box, the solder joint came off, and we were in between shots, and it was daylight dependent, and yeah, the pressure was on. So because we didn't have a cable nearby, like it was far away, the truck was far away, I literally just asked special effects and electric to borrow their soldering kit, and I got up on a ladder and I undid the cable and I resoldered the connection real quick. I didn't have shrink tubing, so I used electrical tape. And after that, after the day, we took that cable out of commission and replaced it, but it got us through the rest of the day. So it really does help to have these skills. And yeah, I feel like other departments are always happy to help if it's something technical for some reason, because it's more than they get to, it's just something different. Breaks up the mundane.
Yeah, one good add-on to that story is I remember a bunch of years ago, I had my voltmeter out and we were building a Steadicam, and the Steadicam guy pulled out a 3-pin cable, it was a 4-pin cable, and he's like, I can't remember if this is correct for my rig. It was like an old cable, and so we tested it, and it was actually a 4-pin 24 volt cable, which is kind of a nasty surprise. And had he plugged it in, it would have ruined his day. So we tested it real quick and we put a big old label on it after that.
Interesting. Because I know that you can wire 4-pin for both 24 and 12 by using all 4 pins.
But you should label the shit out of that cable.
Oh, yeah.
If you're going to make something non-standard, just label it.
Yeah, I mean, even though I think it was the Sony F65 accepted 12 and 24, we only ever did 12 volt because we didn't want people blowing stuff up. Sorry, it's going to take a second. So I want to include the shielding, since this is a 4-pin male XLR, which means that it is going to go into a battery. So it is the power source end. You want to include the shielding.
Yeah, Carlos makes a good point that there's no standards. There's just typicals.
Yeah, that's very true.
So you mind walking us through what you're doing? Because this is live. So if anyone has any questions, Melissa can show you right now.
Yeah, I did the razor blade to cut off the black insulation. And this shielding is actually braided, so it takes a little more time to get it off of the connection. If I wasn't using the shielding, I just cut it all off. But since I want to use it, I got to be a little more gentle with it so I can turn it into a conductor.
Yeah, when would you want to keep the shielding and when would you not want to?
You want to keep the shielding for the connector that's going to go into your power source. So if you're making a P-tap connector, which is going to go into an onboard battery, that's when you use the shielding. If you're doing a 2-pin LEMO, which is going to go into like a Teradek receiver, don't use the shielding. For the power source end only.
Well, what if it's a 2-pin to 2-pin coming from onboard power from the camera going into a Teradek?
That's tough.
Is it mostly important when it's coming from the main source, like the P-tap on a onboard battery, or the XLR coming from a block?
Yeah, my gut instinct says that it's for, because the power ports, those auxiliary, those accessory power ports on the camera, they're regulated. So they've got boards and protections in place. So my gut tells me that it would be more, it's more important to do it for the side that's going into a battery. Like, I don't even know if you'd necessarily, well, I don't know when you would actually do it for an AC. Like, I don't even think you would need to do it for an AC power, because if you're, you know, chopping off an AC end, AC power end, like that would. Yeah, my gut instinct is to not do the shielding for the 2-pin to 2-pin and just for batteries.
Okay, and a follow-up question would be like, let's say you want to make a custom length XLR 4-pin, but it's 4-pin on both ends because you're going to come from a block battery into the back of a Flanders monitor or some other powered device that takes XLR. Would you then tie the shielding in on both ends of that?
Yes, but you got to make sure that, I mean, I don't think it will cause a problem. Would it cause a, yes, I would do that. But I'm wondering if it would cause a problem if you use that cable for something else. Like if you plugged the female in like into the back of something that takes that has a male XLR on the back of it.
Yeah, to keep yourself out of trouble, just shield one side of the thing. Yeah.
So just the battery end.
Yeah. So you don't have
But yeah.
For the shield to function, it can't be conducting current. That's not the goal of the shield. The goal is to specifically not do that. So if you have it connected on both ends, depending on what you plug it into and all of the little details added up, it has the possibility of passing current through there. If it's open on one side, it can never possibly do that. So it provides at that point, it provides a barrier for anything to get through it. And everything has a single point of ground to go to. Anything that it receives, any radio frequencies, electromagnetic interference that it receives, it has a single point to go.
So
yeah, so make for safety only to ever do the one end, and then for the 2-pin to 2-pin, don't do it on either end.
So when we make our own extension, like a 3-pin or 4-pin XLR extension cable, we should just pick an end to tie in the shielding to and not do it to the other end. And then the end user really doesn't know, and it doesn't matter.
Yeah, for the most part, it's just not that critical. And like on the power side of things, you know, you kind of do your best to, you know, creating some shielding is good, but the, you know, power should not be carrying signals, and almost any modern device is going to have multiple levels of filtration between the power input and the actual delicate signals that whatever that device is dealing with. So it's not critical like you would find with like super high speed communications cables. So yeah, just do one side and not the other, and it's not extremely critical. But you know, I would usually put it on the device side though, so at least the shield is at the exact same potential as the negative return of the sensitive device, as opposed to the, you know, on the power side necessarily, because the power supply is actually what's delivering the noise. Usually, not a battery, but a switch mode power supply would.
Hey, Chase Abrams has a question. Chase, you want to ask your question?
Hey, hopefully you guys can hear me. I have shit internet. Going along that question or that line of questioning, you know, I've done cables for all the. I've done soldering for all the cables in my rack for a couple years now. I don't believe I did any of that tying it into the shield into the power side. My question to you, should I be redoing these cables? I have, you know, is it 911 critical, or just going along what Carlos kind of said? Is it kind of something that, yeah, it'd be great if when you made the cable you did that. What do you guys recommend for cables that are already pre-made mistakenly without the shielding tied into the power side?
Do you want me to take that one, Melissa?
Yeah, I'm sorry. I'm trying to figure out how to turn off my lock screen, because basically my phone froze on me.
There we go.
So Chase, I wouldn't bother for 2 seconds worrying about that.
Okay.
Yeah.
Tearing apart the card and all that kind of stuff. I mean, the majority of the stuff that I wire up, I don't use a shield on any of the power wires. Like if it's available, yes, I'll sort of do it, but there's no way I'm going to spend my time going back. It's truly in that precaution category, and that's
yeah. It's just a way to make them safer. Like unless you're having electrical interference problems, I wouldn't touch your cables on your card.
Okay.
Yeah, and in this case, if you wanted to do something to do a precaution after the fact, snap-on ferrite are a good way to do that. Just snap on a ferrite on each end of the cable, and you know, that's at least a good precaution. But you can just snap those suckers on at any time. It doesn't require any cutting or soldering or anything.
Okay, great. And just to confirm, just because this is a 101, snap-on ferrite, it's those little circular things that go on cables, right? Am I, just to ask the stupid question?
Yeah. So it's a plastic shell usually, but with a ferromagnetic material on the inside that absorbs high frequency noise, which is what you're trying to get rid of. And
that's awesome.
And it only allows the DC to pass.
So that's like, that would be a great purchase for, say, you know, cables after the fact, and we wanted to just insulate them more and protect them for, say, power cables only, and we could do that pretty easily with these little clip-on, snap-on ferrite things.
Yeah, exactly. I mean, you see them on like on monitor cables and like all the pre-made like all this stuff. They're all over the place. You can buy the kind that you can install yourself and just stick them on there, and yeah, they provide some level of interference reduction. And you guys are working on your carts are jam-packed full of all kinds of stuff that, you know, there's trillions of bits per second floating all over the place, and you've also got, you know, the AD standing next to you with a 5-watt walkie-talkie.
Yeah.
And so that those two things, you know, they generally don't go that great together. So you know, taking some precautions, I think, is reasonable, considering the consequence of even a tiny error is pretty huge. You know, it's a drop frame, it's a drive that drops off, and you have to remount it in the middle of a data transfer, you know, whatever the case may be. You know, those kind of annoyances to some extent can be avoided by, you know, shielding, ferrites, all that kind of stuff. But, you know, 911 emergency, I don't think so, personally.
Awesome.
So
Thank
if you were noticing issues, Carlos, like you mentioned, then you might start to troubleshoot and think that your cables might be causing those issues that you were mentioning, right?
Yeah, indeed. But it's in my experience, most of the interference issues that I've seen creating real problems is usually just a piece of crap switch mode power supply, either a DC to DC converter or an AC to DC converter. The ones that aren't shielded, the ones that are a bit out of control, the power supplies create probably by far the most noise out of anything else in the system. And, you know, like the random, you know, stuff that you get from, you know, who knows where, and you know, it comes from Amazon or whatever. That doesn't mean that any Amazon power supply can be bad, but usually those kind of like random no-name brand things, they emit like an AM radio station, all kinds of noise that can, you know, cause problems. So keeping the power supplies far away from the sensitive stuff is a good idea too.
And those ferrules that you put on, is that both sides or just one side?
It can be one or both sides. And it depends on what, like if you plug something into a Teradek or something as an example, and the other side is a battery. The battery is not going to be generating any noise at all. The Teradek, even though the current is the Teradek is what's consuming the electricity, the power supply inside of there can actually can create the conducted noise that goes back over the cable, and then that cable becomes an antenna for to be transmitting whatever electromagnetic radiation. So in that scenario, just having a ferrite on the Teradek side would be helpful. If you take the battery that's powering the Teradek and replace that with an AC power supply, now there's a reasonable chance that the AC power supply is creating even more noise than the Teradek is, and then having a ferrite on that end is more important. So if you have it on both ends, it kind of covers you for whatever scenario you have, whatever scenario you're dealing with. The goal is to try to eliminate the wires and the cable from becoming an inadvertent antenna that's radiating the stuff. So that's why they put those the ferrite clamp on so close to the connectors.
Got it.
Unlike regular computer cables and stuff.
Thank you, Carlos. Hey, Melissa, would you walk us through what you're doing so people don't miss this?
Yeah, sorry. I hope people have been able to watch. So basically, I stripped this insulation. I combined the blue together and the white together. Since there's no black, I'm going to make the white the ground. And then because this end is going into a battery, I'm including the shielding in the ground conductor. And yeah, I just twisted all those together. I primed it with the flux. And then I just barely touched just a little hints of solder to it with the iron. 1, 2, maybe 3 passes on the shielding one because there's a lot more copper to cover. And now I'm prepping, and I put the back cap on because you don't want to forget the back cap before you put the pins on. And now I'm prepping the actual XLR connector with solder.
There you go. Don't forget to put that twist connector on before you start soldering. Otherwise, you won't be able to get it on after you make the connections.
Exactly.
So do you find yourself doing this preforming pretty often?
Pretty much every time.
Yeah?
Yeah. It just makes it so much easier to fill the cup versus just holding the solder and continuing to like just fill it with solder. Like if it's already filled to the top, then you know that it's got the proper amount of solder in it.
And one thing to point out too, guys, when you're looking at those pins, there's numbers next to each pin, and those correlate to pin 1, 2, 3, and 4. So when you're wiring up a block battery or something like that, a cable for a block battery, you want to make sure that your hot is going into the right pin based on the diagram off the block.
Yes, this is 1, 2, 3, and 4. 4 is going to be voltage.
Yep.
1 is going to be ground. Just cleaning up extra flux because that is conductive. So if you see like you got a good amount of flux going on, you want to get that off. In my wish list from Carlos's class, I included acid brushes and denatured alcohol, and that's a much better way to remove excess flux than my little precision tweezers.
One thing to be careful too, if you don't do the preforming like Melissa does, I've seen connectors that I've opened up where someone tried to like melt the solder into it and it overflowed and some of the solder was touching the next connector. It was really, really sloppy work. And granted, there was no pin going through the next connector, but man, you don't want to have anything like that. You want the solder to stay in the cup. Would have been a pretty obvious thing, but
if you see that happen on a connection that you do,
yeah, don't clean it.
Just desolder it. Just desolder it and resolder it. You haven't ruined anything. Like you can always go back as long as the pins are still being held in that plastic chassis. If you've gotten to a point where you've desoldered and resoldered so often that the pins literally melt through the plastic, then you'll need a new connector. But you know, I always buy one more than I need because you never know. I'm cutting my shrink tubing.
Does anyone have any questions about the process?
See, this is a little short, so I don't have any working space. So if I put the soldering iron to this, the shrink tubing is definitely going to melt before I'm ready for it to. Sorry. So what I'm going to do is I'm going to cut back a little more of the black insulation and just make my conductors a little longer, give myself some actual working space, which is something that I have to do often sometimes. There's nothing wrong with it. Just means that you want to get it. It's basically just like thinking a few steps ahead of your current step, so you don't end up having to redo the whole thing.
And as you guys start to build cables too, you'll see that the space and what she's trimming off, if you trim too much, your cable becomes floppy, right? If the connector that slides into the 4-pin part and twists, if that's not grabbing onto the actual cable, like if you trim too much off and it's only grabbing onto the wires that are in there, it's just going to flop around. So there is a sweet spot of trimming. It's just like making a BNC connector. If you trim too much, you're making it kind of a shitty cable. And if you don't trim enough, then there won't be enough room to work. So there is a small margin of error, but it just takes time. Now's a great time for anyone who wants to learn how to solder. You've got all the time in the world. Just practice making these at home and try different things so you can see different measurements and different approaches.
I keep forgetting that I can't move my my vise because I got a camera on it. I usually move the vise quite a lot.
That's pretty good right there.
Yeah, since this is a big connection, I'm going to go ahead and also put a little extra solder on the iron, even though I've got the iron tinned, or sorry, the cup tinned and the connections tinned. Just because the shrink tubing go. Nice. Yeah, the shrink tubing shrank quite a bit. And you got to be really careful with this method, because if you puncture the shrink tubing, it's useless. And you got to desolder and resolder.
I forget the name of them. They also make those little scissors that you can clip onto the wire just before the insulation starts, and it helps pull the heat.
Yeah, you were telling me
Helps
about
pull
that.
the heat generated by the iron towards the scissors. They're like these little metal scissors, instead of the heat going up the cable and then melting the insulation and then the shrink tube that's around it.
Yeah, you can also do that with your blunt tweezers, if you like. Instead of holding it with your fingers, like you hold it with blunt tweezers, that will also absorb a little bit of the heat. It'll create like a little bit of a barrier. Sorry guys, I gotta take this out of the vise so I can get behind it. There we go. Trying to loosen it. There we go.
So you're redoing it?
Redoing it?
Yeah.
No, I'm doing the other end.
Got it.
So yeah, I turned it around because I always want the end facing me that I'm working on, so I can really get a good look at the webbing. This one should go in a little easier because it doesn't have that shielding. It's gonna have a little extra flux. You can tell it's there because it's not silver. If it's like brown or like amber looking, try to get that off. There you go. Yeah, you want to make sure that the shrink tubing covers the pin and protects it from the surrounding pins. And then, yeah, just for extra safety, why not? No, it shouldn't affect anything. I cover the shielding in electrical tape. It shouldn't come into contact with the pins, but if there's room for electrical tape, why not? Yeah. And what's nice about the XLR is that the collets have a a split in them, so you don't have to put the collet on and make your workspace even shorter before you put the pins on. You can do it afterwards, basically. Snap it on like that. And you want to line up the keyway with that guy. Look like that.
Nice.
Did my phone fall asleep again?
Oh.
I don't remember where the lock screen settings are.
Just a point of clarification. I think earlier I said that Panavision's 4-pin is backwards. I think I meant 3-pin, so sorry about that. Their 3-pin configuration is different than everyone. I won't say backwards. But.
Come on. Okay. There we go. Oh. Yeah, get the collet on there. Put the keyway proper. To do. There's not a lot of space to show you how to do. I'll just have to do it a big way. You want to just spin. You want to just spin the outer casing until it wants to fall down. Do not force it. There you go. Now you don't have any space between the connector and the shell. And then this is another thing that I see rushed. Make sure that it's lined up properly so you don't get cross-threading, because otherwise you won't be able to get a good squeeze on the collet if you can't thread it all the way up, or, you know, as far up as you can go. No, open a car. What I'll do, so we can check continuity, is I'll cut away with this. That's basically it. If you guys want to see more soldering, I have a couple more cable videos I could show you if you miss any of the live soldering.
Any questions about the 4-pin connector?
For higher current stuff, have you ever tied pins 1 and 2 and 3 and 4 together?
Not on XLR connectors. We've never had any devices that require that, or batteries aren't wired like that, or Tesla batteries weren't wired like that. But they're like the 8-pin female Alexa mini cable. Those have tied pins. I think it's like, I can't remember off the top of my head, but it's at least 2 pins are tied together for positive and for negative. So in that case, you could create a solder bridge between the pins, which is how I've done it. But Carlos also let me know of a good method, which is to split the conductor between 2 pins. So you basically, you spread out the copper and split 1 copper conductor between 2 pins, and that's another way to bridge 1 conductor to multiple pins. I'm just trying to get some space. Need space. Oh my goodness. This is some like trashy 2-pin conductor wire that I found lying around. I just used it for the split cable demo, but I don't like it. I feel like I never want to have, as long as there's space for it in the connector, I never want to have less than 4 conductors.
Are you using that same Ogami 2893 for the XLR 4-pin?
So no, I'm using the Canary L4E6S, and that's because I used it in the split cable. So since there's multiple devices, which could potentially, double the amperage pull, I'm using the thicker gauge wire than the Mogami 2893. The Canary L4E6S has thicker conductors, and I combined them so it makes it even thicker gauge. Just because it's going to be pulling more amperage than, a single cable would on its own. All right, so I'm going to check continuity. Good Lord. It's really open. Okay. Do that. The red is the positive. That would be pin 4. There you go. You hear the beep.
The beep is good.
And the pin 1 should be the ground. Rawr. I heard it for a second. Ah. Sorry, I'm having trouble holding the whole thing together. Ay, ay, ay.
Did we make a bad cable?
I don't think so. These leads are really tough to deal with, these tiny connectors. I've got other leads, but I was just trying to do this fast. So I was not changing out the leads. But yeah, I've got the little like alligator clip, not alligator clip. It's just like a little grabber. So I put a little piece of the like conductor, like single strand wire, and attach it to the grabber, and then I can put the tiny little wires to the 2 points, and it's just here. It's just
Okay.
it's just tough because
We can move on to the Y cable.
Of most.
Let's move on to the Y cable.
Yeah, no, it's just because I just want to make sure this is done correctly before I move on. All right. I can't seem to get the signal. So maybe my Y. I had a signal before. Oh, there it is. A beat. There's this weird thing inside this conductor. I've not used this cable before. Carlos, do you know what that is for? Can't even see it. See that white stuff inside the conductor?
It's like a plastic thing. Yeah, it melts when you solder
There
it.
it is.
Oh, yes, sorry, I got distracted.
Yeah, that white stuff was getting in the way. But now, yeah, I've gotten 2 beeps. Beeps are good.
The fiber stuff that's kind of intermixed with the conductors.
Yeah.
It's a strength member. It's like, I think it's nylon in most things, but it's there just to provide strength so that when you're pulling on the cable, that's a non-stretchy material, so that'll take the heat, the physical force before the copper gets stretched. And it's also there to make it more difficult for you to solder.
Yeah, it was definitely, I thought I was making it easier on myself with 2 conductors. Yeah, it definitely was harder to solder.
Yeah, I think that they make it that they call it's a strength member.
Split cable. All right, I'm gonna pull up the split cable. Oh, does anybody have any questions? I guess we already covered that. The XLR. Anybody have any questions about the XLR? All right. So building a split cable is in some ways easier and some ways harder because there's no cups to solder into. There's no pins to solder into. But you're dealing with like free floating wire. So you don't have anything stationary to really get into. Everything's just kind of like, you just got to find a happy medium and connect the 2 ends. So yeah, cable.
So this kind of cable is super useful if you want to power, like, say, 2 box IOs off of 1 cable and save a connector.
Yeah, I know Tyler had, you know, he ran out of ports basically on his battery and he wanted to power more devices. So I made, I think 2 3-split cables for him.
Ran out of ports?
Mm-hmm.
Crazy. See, I put a scatter box inside mine. So I have 1 cable going to a scatter box and everything's powered off of that. And I have like 8 available XLR ports on my battery left.
So yeah, so since this end is going ultimately to the XLR end, I'm including the shielding in this end that I'm connecting because I know that it's going to the battery and only to the battery. It's never going to be used opposite. So the thing with a wide cable is you need to pre-plan your shrink tubing pretty methodically. So you want shrink tubing to cover the point where the black insulation gets cut away. So you want a shrink tubing to cover part of this on both ends. You also want shrink tubing to cover the entire connection. So including the XLR end over here. So you really have to pre-plan, pre-measure it out as much as you can because you need to put all of that shrink tubing on the cables before you solder them together. Because we're assuming that you have ends on these. So you have to put it on the open end because otherwise you're never going to find shrink tubing that can go over both connectors but also shrink down small enough to protect your split. So it's just a lot more planning ahead for shrink tubing. Yeah, I like to do this little trick when I've got the 2 together. Oh my God, what happened? When I have the 2 together, I use electrical tape to tie them together, the 2 cables. And that makes it a lot easier to deal with. You don't just handle. They're basically acting like 1 cable. So it's just a lot easier to deal with when you start soldering the Y pin on. Yeah, pre-measured both types of shrink tubing. This is the L4E6S, which you just watched me deal with live. Creating the shielding ground, since this is going into a male XLR. Because this is just a split cable and it's not going to any pins, it's really up to you how much copper you decide to strip off. Like, there's no set standard. You just want enough so that you can lay them on top of each other and make a good connection. Yeah, here I am measuring out the big piece of shrink tubing that's going to cover the entire Y split, in addition to the shrink tubing I have right here and on the other end. Yeah, I've made analog microforce cables from scratch with just this method. And that's it. If you got solder primed on both ends and you put a little bit of solder on your iron, it yeah, barely takes a second to make a good connection. But it does take a steady hand, so maybe don't do it right after you've had your coffee.
Do you have any tips for this part when you're trying to join two cables together that are almost fighting each other?
Steady hand. Tying the two cables together really helps. Putting it in a vise. This might be a good opportunity for you to also use helping hands. If you want to hold the other end of the cable with the helping hands, that way you only have to use your hands to get the two ends to meet, as opposed to also trying to like handle both cables. Yeah, the vise is very helpful. Tying the two cables together with electrical tape is very helpful. And honestly, I guess it's like shooting a gun. Like, do it as you're breathing out. So your hand is like extra steady. And it doesn't like go around like that, because it's a very, very small connection you're trying to make. But it can be done.
Yeah, I think important thing to notice right there is that just where you slid the shrink tube over, that's your connection that's feeding power to two devices. So just test it, make sure it's solid. If it's cracking or it doesn't look like it's a great connection, just make it right, you know, because that's going to be something that you're going to have to troubleshoot later if you don't do it properly.
I've got that. This is also where I really like to have a torch instead of a lighter, because the lighter gets really hot because it's a and then finally I would put that last long piece over and also heat it up, but I wanted to save the shrink tubing for a real application, so I didn't heat it up, but that's basically what it would look like.
Does anyone have questions about making a Y cable? Super useful, especially for our applications with like low amp devices, low voltage devices. If not, we can show removing solder real quick and then take any last questions.
Yeah, so I got a little video for this too. You might have seen it in the live. I did use the desoldering braid. So this is me harvesting a connector from an old cable. So I use the razor blade to cut off the old shrink tubing. But again, you want to be kind of careful. You don't want to damage the pin or the plastic that holds the pins. You can damage the wire all you want because it's just scrap. But I find it's easier to leave old wire a bit long. That way you have something to grab onto when you're taking it out of the cup. Because the last thing you want is like little bits of old wire in the cup that you're trying to put a new wire and new solder in, because it's just going to contaminate it. Yeah, you apply flux to the desoldering braid, like maybe an inch worth at a time. Then you touch the iron to the braid, to the solder that you want to remove. And then this braid will literally suck the solder right up into it. You might have to touch it to it a few times to avoid overheating the pin. But yeah, that should get most of the solder out. And then you can use your iron just for a second, just to get that last little connection out. Once you put solder in the braid, cut that part of the braid off. Do not try to put more solder in it. As soon as it's silver with solder, it is no longer going to suck up any more solder. So you just, yeah, I've gone through a lot of this braid. It used to be full, but every time you use it, you want to cut the part that has solder on it off. Yeah, it's just a much cleaner way of removing solder. I definitely wouldn't recommend just adding new solder. I would definitely recommend removing the old solder first, just because you're going to get a much cleaner connection. You're going to get less contaminants in your connection, etc. Yeah, you can see it travel up the braid. That's basically it. That's all she wrote.
Sweet. Let's open this up to any questions you guys might have that maybe Melissa can show live if she's prepared for it. Any questions? Because I think we're in a good spot where I guess we've covered everything we wanted to, right?
Can I chime in right now?
Of course. Anybody can talk. Unmute yourself.
Great, thank you. You might have gone over this, and I had to step away at the very beginning for a bit. The biggest struggles I've had are with trying to understand how much wattage to have. Like, if it's larger components, I'm just sitting there forever, you know, holding the iron onto the connector, just waiting for it to be hot enough to heat up the item that I'm applying the solder to. So sometimes it's like, am I using the right bit? I do have different ones. I don't always know how to use them. Do I have enough wattage? You know, is my soldering gun dialed into the right temperature? Can you speak to all that, and also to how you would choose a different soldering iron and or wattage / heat versus what it is you're soldering? Because sometimes it's bigger pieces of things that I have to solder, and sometimes it's the really small connectors, you know, like a Ethernet, you know, 8-pin Fisher for Ethernet or something. So that's where I feel like I struggle the most.
Well, I find that if the iron itself is in good health, the tip is in good health, and you've got a good quality iron, one of these with like an external power base, not one that plugs not one where the iron plugs directly into the wall. I find that 750 degrees can handle pretty much anything. I think tinning both ends of the connection with solder will help, because it will encourage new solder to connect to that other solder. So you might get a better, more efficient flow then. But I remember from Carlos's class, he mentioned that there's a tip that might not actually be better for the larger connections. It's like a big, like almost, it looks like a flathead screwdriver tip versus these like almost needle tips. And that might be better if you're doing like very large connections, because it's just more surface area for the heat to travel from to get to where you want it to go. Does that answer any of your questions?
Yeah, it does. Could you, what was the model, the exact model number, and what's the street price on the one you're using?
I'll have to look it up, but I feel like it was not that expensive. Oh, this is a WE1010. So can't use my phone at the moment because it's another camera, but we could see what Amazon says.
So do you mind if I chime in while you're looking up that price?
All right. My internet's very slow. It's being taken up by this Zoom meeting, but it was not that expensive, if I remember right. I think it was under $100. And I mean, we used an analog version of this at Keslow for every technician forever. The only guy that has a much better soldering station, and that's probably similar to what Carlos has, is the R&D technician, the guy like that's literally building boards all day long, that needs all the different tips, and he's got the desoldering vacuum and all that good stuff. But just for basic assembling of cables, I feel like this WE1010 has been more than sufficient for my purposes. But I guess if you're doing like super massive gauge of cables on a regular basis, I don't know, Carlos, are there heftier irons that produce more heat?
Yeah, can you hear me now?
Yeah.
Okay, good. Yeah, so my goal is never to make the iron hotter. It's to make the joint hotter. And I think that's the conceptual difference there is really important. And like, for example, the hottest my iron ever gets is 650 degrees. And that's for like the most brutal, like bridge building, heavy conductor, you know, all that kind of stuff. And that helps me to prevent melting the jacket and all those kinds of things. And the difference between, you're asking about a soldering iron, that, you know, the difference between, you know, the cheap stuff and the expensive stuff is, it's a term called thermal recovery. And that is related to where the iron actually generates the heat and how it senses the heat falling. So in the lower end irons, the heater is kind of up in the handle, and it heats up a really big, heats up the entire tip, which is actually fairly long. And the sensor that tells the control unit how hot the thing actually is fairly far away from the joint as well. So there's a delayed reaction there. On the higher end soldering iron, the heating element is in the tip itself. I mean, it's like right next to where you're actually soldering, and it's coupled with the temperature sensor. So at that point, you don't need that much heat, because as soon as you touch the joint, the temperature starts to drop. The base station instantly knows that the temperature is dropping. It starts pumping the heat back in there to try to keep that heat stable. Whereas the cheaper irons, that might start at 750 degrees in free air. The instant you touch that joint, it goes down to 550. It goes down to 400. It goes down to 350 really, really fast. And keep in mind that the solder itself, especially the leaded solder, melts at about 220 degrees Celsius. I don't know what that is in Fahrenheit, but that's I run my iron about 325 to 350 Celsius, with, you know, about 100 and something degrees above that melting temperature. And so you really never want the joint to be 750 degrees or even 650 degrees. That's just kind of how you get that heat into it without it having time to disperse to everything else. So I think that's the big difference between the cheap stuff and the expensive stuff is just how well it controls that heat. And it doesn't sound like a whole heck of a lot, but I distinctly remember the glorious day that I finally got a real professional soldering iron. And you know, at first I thought soldering was extremely difficult. I thought I was never going to get it. I thought I was uncoordinated, didn't understand it. I had bad solder, I had bad everything. And then I got a proper iron, and I was like, oh, this actually isn't that difficult. It made that much of a difference. It was a complete night and day difference that was less related to my personal skill and more related to the limitations of the equipment. And so the next consideration are the tip sizes. And generally speaking, you want the largest tip that you can physically fit into the area that you're soldering. So the bigger that tip is, the faster it will transfer the heat. Melissa covered that, super important, but also keeping the tip really, really clean. A dirty tip doesn't transfer the heat from the tip to the soldering joint very well. And so what you end up with when it's kind of poor conduction from heat from the tip to the joint itself, it will, that's when the whole thing, the connector, the housing, the jacket on the material, on the wire, it all starts to slowly heat up. And then you have, you know, goopy plastic stuff kind of going everywhere, and the pin has kind of melted out of the position of the connector. And I'm sure Melissa's seen that herself. I've certainly seen it a bunch of times. There's some gnarly connectors that have my name on them somewhere from that kind of thing. So the bigger the tip and the cleaner it is, the easier it is to transfer that heat as fast as possible into the solder joint, get the solder melted. As soon as it flows, pull the tip away, and you should be good. If you don't see that, don't just apply more heat. The answer is not to crank up the iron to 1 million.
And flux.
Yeah, well, yeah, flux is an ultra critical part of transferring the heat. The two things that flux does is it cleans the joint chemically when it gets hot, but it also allows the heat it facilitates the conduction of the heat from the tip of the iron to the joint really, really fast. And so those two things together make the soldering process not just easier, but possible. Like you can't really make a solder joint without the flux at all. And if you get the right amount of flux on there, it drastically reduces the amount of time you have to apply the heat to the joint.
Yeah, like a quarter of the time, if not more. So if you haven't used flux, try that first. Yeah.
And even I know you like to you like pre-tin the wires and do the preform on the cup. Do you ever put solder? I mean, not solder, but do you put flux on those pre-tinned joints just before you do the final connection?
No, but I wouldn't be opposed to trying it. Anything to keep the soldering iron tip to the joint as little time as possible. So I'm all about trying ways to cut down on the amount of time that the tip is in contact with the connection. So I'll definitely try that.
Yeah, you said you got the flux syringe, so that might make it a little bit easier to apply just like a little bit to each side.
Yeah, and I do realize that I did forget to mention that with these tips, the whole tip does not heat up. There's only one specific point near the very tip that heats up. So you have to find that point and only touch that point to your solder and your joint and whatever you're trying to heat up. Because if you put the back end of the iron to it, it's just not going to transfer heat very quickly at all. You need to turn the iron until you find the hottest point, at least for this tip.
I never realized that that must be a Weller thing.
Maybe.
Spend the money on a good iron.
Yeah, this was $111 is what it's listed for on Amazon, but I've had no problem with it personally.
Chase Abrams has a question.
Hey, so I've already made all my cables. I guess I'm just looking to gauge rate of repair. I did all my cables with no flux, so take that in mind.
Oh, fuck, Chase.
Yeah, I know. But you know, it's like I'm just trying to gauge in my head. Like, I know Neon Lives had this problem where after 5 years your battery might die. You know, so I'm just trying to mentally think of all these things. You know, it's when backup cables become necessary to have. All the time. What do you guys think? Like, what have you seen in terms of lifetime on just cables you guys have made?
I would definitely say that cables that I've made poorly lasts a lot less time than cables that I took the time to do all these extra steps. But I didn't have all the information when I started soldering. So like, I definitely wouldn't take out your cables until they break. But just when you repair them, just definitely use all the tips that you've learned today.
I think it totally depends on what you're using them for. If they're going on a camera and they're just going to get twisted and bent and really like, you know, abused, then yeah, you really take your time with it. But if they're just sitting in your cart or in your rack,
yeah, they're probably a lot less likely to.
I've been very fortunate because these have lasted 2-3 years, and so it's they're sitting inside my rack. So.
Oh yeah, you shouldn't have a problem. I can't imagine you having.
So keep in mind the solder itself has flux inside of it.
Right.
So just because you didn't apply sticky flux or pen flux or liquid flux, whatever, to it explicitly, there was still flux in there when you did the soldering. So kind of depending on how you did that, you could have gotten perfectly suitable wetting just like that without using any flux at all.
Yeah.
The flux definitely makes it easier, but if you just use pure solder, which isn't even available as far as I know, not in a wire form anyway, that would be a problem. But pretty much all wire solder has a flux core of some sort.
I see.
Okay, so probably fine.
Hey, Carla, I'm looking at my Kester stuff here, and I'm looking for it to say that it's got the lead in it. It says rosin core. Is that the same thing?
Yes.
Okay, so that's the flux inside. Okay, I was thinking.
Yeah, rosin is a type of flux, rosin flux.
But Ben, I have the same thing, and you see a big difference if you add external flux along with that. There's not enough flux in there to speed up the process, like what she was showing.
I do add the flux as well, so I just didn't know that it came inside the solder as well. Although I wasn't adding it to the braid to soak up. Didn't think of that. So thank you for the tip on that, Melissa.
Yeah, that definitely does help. It's pretty much a mess if you try to do it without it. It just ends up burning the braid.
Yeah, the Chemtronic. Do you use the Chemtronics braid? The Chemtronics braid has quite a bit of flux put in there, and it's pretty high performance.
Yeah, I don't use one with the flux inside. I've never used one before, so I never bought one before. I just always have gotten used to applying the flux myself. But yeah, they do make desoldering braids with flux inside, so that might be a good idea as well.
Oh, my braid says rosin.
Yeah, I mean, sometimes I'll put flux on it, and sometimes
more flux is always.
What was that?
My braid says rosin.
Yeah, exactly.
So
I mean, flux does make a mess if you use too much. Yeah. So it's got some embedded flux.
But if you're having trouble getting the solder to stick, chances are a little bit of flux will help.
Yeah. All right. Anything else you guys can think of? Any last questions? Ask away, guys. And also, before we end, we're going to try something new here just because Melissa put in a bunch of time to develop this for us and spent money on connectors and refused to take my money. So we're trying like a tip your bartender kind of approach here. So if you guys want to throw Melissa a couple bucks through Venmo, she's going to share her QR code. You can open Venmo and take a picture of the QR code and send her whatever you think is fair for her time and her energy and her materials to help teach. Anything will be greatly appreciated.
I call it the Mel desperately needs the manicure.
Yeah.
Fund.
We're going to get her like 3 or 4 inch nails. So the next class that her nails get in the way of the teaching. But yeah, we'll post a link to all the products that we were talking about as well, just so you guys can put together, a real easy list, and just for the things that matter, spend the money on the soldering station and whatnot. Just start with the right thing, because you'll have it forever if you buy the right thing. So
before we end, I did have a couple of closing things to talk about.
Yeah, Carlos, I have the Hako model as well, and it comes with tips and accessible tips or additional tips. I'm happy with it. It's real simple. I think it was $100 or something like that.
Yeah, I feel like the $100
really, they're super popular. Lots of tips, decent tip life. And, you know, not so expensive that you know, you're.
Melissa, what are you gonna say?
I just wanted a couple of last things before we close out. There's other things that you can do once you have these basics down, like the Y cable and stuff like that. I've started adding inline voltage regulators to my cables. Well, I mean, I've done it for a long time, but you can find these tiny little, this is a 5-volt regulator. And that could very easily, if it's going in your rack and not going to be, you know, run over by a dolly or something, you can very easily just cover this in shrink tubing once you wire it properly and put it in line with your cable. So you can use your 12-volt system for a 5-volt product. I've also got a little 9-volt regulator as well. We got to put together some links so people could see it, because I would buy those for sure. Yeah, they're cheap, DigiKey. Another, if you have a voltage regulator or something that's bigger, I find that the plastic covers for the ferrites, if you take the ferrite out, those actually are really great little regulator holders in line of a cable. We did that for a long time at Keslow as well. And then I think the last thing I wanted to show you is how I store my soldering iron to extend the tip life. And that's basically just like when you're done soldering for the day, but before you turn off the iron, clean the iron. And I literally just put a coat across the whole iron, put it away, turn it off. And everyone remember not to inhale any of the fumes from soldering. Use a fan, use a suction thing. Don't ever inhale the fumes that come off the solder. Because usually it's got lead in it, and that's bad. But I think that's generally all I had. The two main things I want you guys to take away from this is I think Chase Abrams has been inhaling solder. That's another mistake he's been making.
Uh-oh.
Yeah. But yeah, the main things I want people to take away is external flux. If you're having trouble, think you don't have enough heat, or you're having trouble getting solder to stick or getting solder out, additional flux, external flux is your friend. It will change your life. Yeah. And then the other thing is make it right the first time. If you mess up, or if you're tired because you've been making cables all day, but you make a connection from one conductor to a pin, and yeah, I mean, it'll be okay, but it's not up to snuff, redo it. It's going to save you a lot of time and grief down the line from it potentially causing a short on set, or just you having to take it out of your rack and repair it like a year later instead of like 3 years later. Hey, there was a request to show your show your QR code again. Oh, then okay. You got it. Anything? Don't be cheap, y'all. Oh, that's the wrong thing. Where did it go? No, that looks right. Hey, got it. Anybody has any last questions? Now's the time. Otherwise, we'll start to wrap this up. And if anybody's already donated, thank you very much. Appreciate it. Yes, I have my phone on Do Not Disturb, but thank you very much for anything right now. Well, we're in lockdown. Yep. I'm glad to hear that at least ITs are getting some work with all the remote stuff going on. Yeah. All right. Yeah, I think that's all. I think I covered everything that I have in my brain. Sweet.
And keep an eye out, everybody, on DIT WIT. Hey, Melissa, leave that up just for one more second.
Yes.
Keep an eye out for the list. We'll put together a list of all the stuff that we were talking about and links to where to buy it, just to make it easy. All right. If that's it, we'll wrap this up. Thank you so much, Melissa. We really appreciate it.
Yeah, no, thanks for setting this up and setting them all up and keeping us informed.
Of course. All right, guys. Thank you, everybody.
See you later.
Later.